Okay, this is the Unit 4 study guide. Some reminders, test is on the Thursday, the 18th. Bring your graphing calculator, of course. 15% is the delta score, right, obviously. And then this is worth 10%, like supplementary. So in case you got like 90% of your delta, this can bring you up to the 100, right? That's how that works. All do by 9:30 a.m. Yeah, I mean, you guys know what to do. You guys know the drill at this point. We're going to do the notes. We'll do them on here. Let's go over some of the key concepts, some of the stuff that you need to know cold. Okay, here we go. The need to know cold definitions for the test. So we have starting us out is linearization, local linearization. It's actually rarely called this in questions. Usually it'll say something along the lines of approximate using tangent line equation. Okay, that's usually what it'll say. And so what that really means is, just to draw it out, it's like if you have a function like this, you can use, and you didn't know what the function was doing, you could actually use a tangent line, let's say like a tangent line, maybe like here, for example, to estimate a value that you didn't know. So like maybe you're using this line to estimate this value, like because you didn't know what the function was doing. That's the gist of it. So really what this means is it's just really two steps. One is find equation of tangent line, which reminder is y minus y1 equals mx minus x1. That's step one. And then step two is just to plug in x value. Okay. The other key thing here is if your function, if f, we'll call it f, is concave up, that's what CC up means, concave up. If it's CC up, concave up, it will be a under approximation. This will be an under approximation. And if it's concave down, it'll be an over approximation. And to show you what I'm talking about there, if it's concave up, right, this is concave up, no matter where I draw the tangent line there, if I draw it here, if I draw it here, it's always below the function, so it's always an underestimate or an under approximation, versus if it was concave down like this, and I draw the tangent line there, it's always an over approximation, right? No matter where I put my line, it's always above. Okay, that's what I'm talking about. So that's it. Local linearization. That's all you need to know. Get the equation of the tangent line, plug in the x value. If it's concave up, it's an under approximation. If it's concave down, it's an over approximation. Okay, multiple derivatives. Okay, this is just, all this means is take the derivative again. That's all it means. Take it again. Or, n times, like some number of times. So for example, like this notation f double prime of x, this means the second derivative, right? This is the second, and then the triple prime would be the third, and so on. That's all this is. It's just taking the second derivative. We're taking it the third time, we're taking it the fourth time. The other notation you can see for this is d squared x over dy squared. This means this is the second derivative. It's the same as that one. Or, d to the third x dy squared. Sorry, dy to the third would be the third. That's what it means. It just means take the derivative multiple times. That's it. Okay. You guys know how to do that. Candidates test. Okay, candidates test. This is for when you're trying to find the absolute max or min. I'm gonna move my hand. I bet that's really annoying. Or min. So, how do you do this? You have to find your candidates. So the candidates always include. So you identify candidates. Identify candidates, which are, there's two types. They are, let me do this in a different color. They are one, endpoints, so just whatever the end that'll be given to you, right? Endpoints of the interval, those are given. And two, the critical points. And that's when the derivative equals 0 or the derivative is undefined. Okay. Then once you have your candidates, you evaluate the function at those values. And then you identify the largest or the smallest. So you have the max and min from that. I could put that below. Then identify max or min. And this is as a refresher. This also kind of includes a table with your x and your fx. And so on the left, you'll put your candidates go on the left, and then the output goes on the right. So we'll do these problems later. So you'll see examples later. Second derivative test. We went over this really briefly in class, and it's a pretty straightforward concept. Just making sure that we're aware because it appears in the AP test. Second derivative test just says if we have a critical point. So if you have the derivative equals 0, right? If the derivative equals 0, a point, and there's kind of two options here. So we have option 1, the second derivative is negative. That means that this must be a relative max. Okay, that's the key. That's key. Okay. If the first derivative is 0 and the second derivative is positive, we must have a relative min. Okay. So why? Just really briefly, I'll go over. I'll do it right here actually. So think about something being concave down. This is concave down, right? The n, concave down. There's no way. It's not. This is intuitive, right? There's no way that this could be a relative min rather. It can't. It has to be a relative max. So this is this example. When it's concave down, it must be relative max. And likewise, when it's concave up like this, it must be relative min. That's what this is saying. If it's concave up, it's got to be relative min. If it's concave down, it's got to be relative max. Okay, I like to label that. This is the blue one, and then this is the red one. Okay. Good. Moving on. Rate in and out. This is really the only two problems that have the calculator are the candidates test sometimes does, and then the rate in, rate out does pretty consistently, like almost always. Let's just say always. You're gonna need the calculator for this one. So this happens when, you know, like rate in, rate out is when stuff is going in and out of a system, basically. Stuff, like anything. It can be people, it could be animals, it could be water, it could be oil, like stuff or quantity is going in and out of a system. And it's worth noting here that this is usually an FRQ, right? This is kind of an FRQ kind of question. And generally what you want to do is you want to first put it in the calculator. So you're going to make like y1, y2, and a y3. And y1 can be your rate in, and that'll be given to you, just put in the calculator. y2 would be your rate out. And then your y3 is the net rate. So it's actually y1, that rate in, minus, kind of going crazy with the colors here, minus y2. Okay, so does that make sense? Like you basically, the rates will be given to you. You label them y1 and y2 in the calculator, and then y3 is the difference between them. And then when you integrate these things, so when you integrate the y1, you are getting from like some a to b, like some usually these will be times. You'll be getting like a quantity in, and so on. So when you integrate these y1, y2, y3, you're getting like either quantity in or quantity out, or the net quantity change. Okay, so I'll keep going. So this is, if you did a b of the y2, you'd get quantity out over a period of time. And then if you integrated y3, you'd get the net change. Right, and this is like all over time, over some time interval. Sometimes there'll be like a starting amount, and it really depends what the question is asking. There's different kinds of questions. We'll go over the FRQ for this, but these are kind of the key points. So there'll be rate in, there'll be rate out. The difference, the rate in minus the rate out, will give you the net rate, or like the real change. And the integrals of those rates tell you different things, but they all tell you a quantity. The change in, if that's not clear, this is a quantity. Okay. Also, really key to this, this test are the product and quotient rule. I mean, these are huge. These are absolutely essential. You have to know this. I'm going to divide this into two parts. So, product rule. We'll call it h of x. H of x equals f of x times g of x. The derivative of h of x will be f of x g prime of x plus g of x f prime of x. That's it. So I mean, you have to know this. Okay. There's not really much more to say about this. When you see multiplication, use the product rule. Like, I don't know, like associate product means like multiply. So when you see multiplication, use the product rule. And then we've got quotient rule. And again, like the order of these don't specifically matter. You could have like the multiplication order mixed around, or the addition mixed around. But the most important thing is just it's one function times the derivative of the other times the other function times the other derivative. Everybody gets a term being the derivative. Everybody gets the term being a function, and they're always against each other. And then you've got quotient rule. So again, quotient, that means divide, right? So whenever you see division, you're going to use this. Let's call h of x equals f of x over g of x. Now, this also confuses a lot of people. It's like, okay, well, sometimes like this function at the bottom is called f of x in the problem, and I think that's also kind of confusing. F and g, the letters are arbitrary. Really, g just means like the lower function, and f just stands in for the higher function. I could call these whatever letters I want. That does not matter. It's just to show you how the derivative is written. So the derivative of this would be is I remember it as low g of x, derivative of the numerator f prime of x minus f of x, derivative of the denominator g of x, all over g of x squared. Okay. And I actually want to shout out Andre. Andre wrote another version of this where he just said it was okay. It's just L dh minus h dl over L squared. And that's like, this is just like another, this is just showing it as like low and high rather than high and low. He actually might have done it with primes. I'm not sure what he did. But he just said like, okay, it's the lower function times the derivative of the higher function minus the higher function derivative of the lower function all over the lower squared. And I like this. If this helps you remember it, use it. The order does matter for this one. So while the order is flexible for the left one, it's not flexible here. It has to start with the lower one. It has to be minus the higher one times the derivative of the lower one. Okay. It has to be the lower one squared on the bottom. Okay, moving on. Chain rule. Okay, chain rule also like huge. Chain rule is huge. All right, so this is if you remember, this is the chocolate one. My great lesson on chocolate, remember that? You have a composite function, h of x equals f of g of x, and you work your way outside in. So you start on the outside, you start with the f on the outside, and you take the derivative of it, and then g of x, and then once you've taken that derivative, then you move into the inside and you take the derivative of the inside. You just work your way outside in. That's it. Chain rule, but it's all over the place. You see chain rule all the time, even in problems that are relatively simple. There'll be a little chain rule in there. Again, lots of problems to do later. All trig derivatives. So the trig derivatives are, and you need to know these: sine, tan, secant, and over here I'll do cosine, cotangent, cosecant. Okay. Derivative of sine is cosine. Derivative of tan is secant squared. I'm being lazy by not putting the x's here. You need the x's. Secant tan is the derivative of secant. Cosine is, I'm putting these in blue, negative sine. Cotangent is negative cosecant squared, and cosecant is negative cosecant cotangent. Just have to know them, okay? I feel so guilty about not putting the x's. I'm going to go back and put them in. Cosine x, secant squared x, secant x, tan x, sine x, cosecant squared x, cosecant x, cotangent x. There we go. Now I'm absolved. Yeah, I mean, you just have to memorize these. So sinus, cosine, cosine, negative sine, all the codes are negative. And there's a pattern. So just you can use flashcards, you use whatever works for you, but you have to know all 6 of these. Okay, they're on the test. FTC with chain rule. We're getting towards the end already of what we've covered. This was the most recent material. FTC with chain rule just says that if you have the integral from some, okay, key here is that you're taking the derivative. You're taking the derivative of some integral from, I'm trying to think what letters were used. I think it was h of x to g of x of some function f of t dt that is equal to f of g of x times the derivative of g of x minus f of h of x times the derivative of h of x. That's it. The one that you'll see most commonly, and the one that really you need to know most, is usually it'll just be a at the bottom. So it'll be like a number at the bottom and a g of x at the top. And this one's easier because you don't have to subtract anything. This is just f of g of x, g prime of x. So if it is ever a number in one of the bounds, that just becomes a 0. So you don't have to worry about it. Okay. L'Hopital's rule. Last couple things here. L'Hopital's rule. Yeah, L'Hopital's rule says that if a limit is indeterminate, then you can take the derivative of the top and bottom. That's like the general gist of what it says. So if we're taking the limit of f of x over g of x as x approaches a, and let's say a limit x approaches a of f of x equals 0, and limit x approaches a g of x is 0, then because it's 0 over 0 or indeterminate, I can take the limit as x approaches a of f prime of x over g prime of x. That's L'Hopital's rule. One of the key parts here is that you have to take the limit of top and bottom separately. That's really, really important. And then you're like, okay, and then I can say, okay, 0 over 0 is indeterminate. You can't just do it all at once. You have to show, okay, top 0, bottom 0, therefore it's indeterminate, and now I can take the derivative of top and bottom and do it all over again. And you can keep doing it. Instead of note, like you can put this over here. You can repeat. If you still get 0 over 0. So if you do this and you're still getting 0 over 0, you just do it again. You just keep doing it until you get an answer. Oh, other key thing is that 0 over 0 is not the only indeterminate form. You could also get, it could be infinity over infinity. There are other indeterminate forms, but really the one that appears in the AP test the most that I've seen, or at all, honestly, is 0 over 0. Like this is what I continue to see most commonly. But infinity over infinity could also appear for sure. So either one of these. Lastly, unit circle. We've been going over this more and more in class. The only things I want are what are called the quadrantal angles. So quadrantal, when you draw a unit circle, the quadrantal angles are just the ones in the corners, or the kind of the compass signs. So we have 0, we got pi over 2, we got pi, we got 3 pi over 2. So you can label all the coordinates. We got 1, 0 here, we got 0, 1 here, we have -1, 0 here, we have 0, -1, and that will just really easily let you find the cosine and the sine, because the cosine is always the x and the sine is always the y. So that down here we're like cosine equals x, sine equals y. So radian of 0, cosine of 0 is 1, sine is 0, pi over 2, cosine is 0, sine is 1, pi, -1, 0, and then 3 pi over 2 is 0, -1. And then it just repeats over and over again. Those are the notes. Okay, on we go. So I'm doing this calculator question. Guys, calculator portion of this test will be very small. It's just not a lot of calculator questions. There's not a lot. It's mainly to do with the rate in and out and the sometimes the candidates test. So I'll give you 4 questions here as an example, but you can expect a very small calculator portion on the test. This and the FRQ will be what you get. Okay, so at time t equals 0, a tank contains 48 gallons of water. For 0 to 4, water flows into the tank at a rate E of t equals 12t sine pi over 4t gallons per minute and leaks out at 6t squared over t plus 2 gallons per minute. How many gallons of water are in the tank at t equals 4? So we want a final amount. That's key. When you read these questions, especially word problems, it's so important. What are we looking for? Are we looking for a change in quantity, or are we looking for a final quantity? And here, I want the quantity at 4. This is a final quantity. So what that means is I'm going to need to take that starting number, 48 right here. That's where I'm going to begin. And then I need to add the change. So let's start with the 48. That's my starting. I'm going to have that 48. And then I'm going to add the integral. So again, to get quantity from the rate, you got to take the integral. So we're going to take the integral from 0, starting to start at 0, 0 to 4 of my rate in minus my rate out. So my rate in was 12t. Well, I'm not going to write it. I'm just going to write E of t. E of t minus L of t. dt. Don't forget the dt at the end. That's it. Okay? So this just goes in the calculator. I mean, what you just wrote is like formally the work. Then here we'll just put in the calculator. Make sure you can see this. Okay. Okay, here we go. Let's go ahead and put this in for y1. So it's going to be 12x sine pi over 4x. So pi over 4. Let me put this x on top here. Oop, bad. Right here. Really, the placement's important of that x. Like, let me show you. It's saying pi over 4x. You don't want to put the x with the 4 because that's going to be 1 over 4 pi. Pi over 4x, not pi x over 4. So it's really important it's in the numerator. Or that you just put parentheses around the pi over 4 independently. And then, okay, rate out 6x squared over x plus 2. 6x squared over parentheses x plus 2. Make sure you put those parentheses in there. Okay, now we're going to math. Oh, no, I'll put in y3. So in y3, I'm going to go vars, y vars function y1 minus vars, y vars function y2. And then that's what I'm going to integrate. So we're going to go back. We're going to math 9. And we're going to do y3, because that's my net rate. comma x, comma 0, comma 4. Y3, comma x, comma 0, comma 4. 34.7488, okay, and then plus the 48, 82.75, or 749, either way. Okay, and yeah, I see that answer right here. Okay. 2. A spherical tank contains 81.637 gallons of water at time t equals 0. For the next 6 minutes, water flows out. It's really important to pay attention to what's going on of the tank. At this rate, 9 sine root t plus 1 gallons per minute. How many gallons of water are in the tank at the end of the 6 minutes? So in this case, there's no rate in, it's only rate out. So I'm going to take that 81.637, and I'm just going to be subtracting the integral from 0 to 6 of 9 sine root t plus 1. There's nothing going in, it's just going out. So on the calculator, what equals, let's clear these, and I'll rewrite in here 9 sine parentheses or 9 sine square root x plus 1, close it, looks good, back, and then let's math 9 it at y1 from 0 to 6, we get 45, and then we're going to add, so we're going to do 81.637 minus that, and I get 36.606. I see that answer right there on the left. So 36.606 gallons is my answer right here, A. Okay. The derivative of the function f prime e to the x cosine x squared for all real numbers x. What is the minimum value of x from -1 to 1? So I mean, you're gonna want to graph this, right? Let's start with that. Just put in the graphing calculator. E to the negative x cosine x squared. So e to the negative x, right here, second ln, negative x times cosine x squared, close it. And we're looking at -1 to 1, so let's just change the window to be -1 to 1. And then let's see what that looks like. Okay. What is the minimum value? Well, when I look at this, let me make sure everything's in here right. E to the negative x cosine x squared. Okay. We're in radians. Good. Okay. Yeah. I mean, when I look at this, it's increasing the entire time. But there's no point here where it's not. Increasing. It's like it's always doing that. So if you think about it, like this function is going up this entire time because this is all positive. The derivative is always positive, so the minimum has to be -1. The answer is f of -1 because the derivative is always positive. That entire interval is always positive, meaning -1, it would be its lowest value because everything else past it has to be something bigger than it was at -1. Okay, that's why it's -1. For the number of people who have entered a museum on a certain day is modeled by the function f of t, where t is measured in hours since the museum opened that day. The number of people who have left the museum since it opened that same day is modeled by the function g of t. If prime of t is 380, 1.02 to the t, and g prime of t is 240 plus 240 sine pi t minus 4 over 12. At what time t for 1 to 11 is the number of people in the museum at a maximum? Okay, this is a rate in and rate out question. When you're trying to find the maximum of rate in, rate out, you need to set the rate in minus the rate out equal to 0. So this is people, G of t is people leaving. This is leaving. F prime of t is people entering. So graphing calculator, same thing. I'm gonna put it in for y1 and y2 separately and then combine them. But you could do it all in one as well. I just like separating it out. So I'm gonna do 380 1.02 to the x in my y1. My y2 will do 240 plus 240 sine pi x minus 4 divided by 12, and then y3 will be y1 minus y2. Make sure you're doing it the right order. Like, it's always in minus out. So since f prime is in and g prime is out, it's going to be in that order. And we're going to turn these two off so I don't see them. And then we're going to set the window to be 1 to 11. And then we're going to take a look at it. Okay. I'm going to make the y a little bigger so I can kind of see a little more what's going on. So let's make the y min maybe like 20 and the y max maybe like 50 or so, maybe even 60. Let's see how that changes things. Okay. So I don't need to see really the rest of it. Like, I know this is all positive up here. It's like it's coming down. So if you think about it now, like visually what's going on is more people are coming in than leaving all this time. More people are coming in than leaving, more people are coming in than leaving, more people are coming in than leaving, until you get right here. Right here, all of a sudden more people leaving or entering. This region right here, more people leaving. You see that? Because it's negative right here. So the maximum value is going to be right here. Right? You can see this is a relative max. We're going from positive to negative. That's going to be the maximum. Okay. So to test that, I'm going to get the 0. Where is my cursor? There it is. Okay. 1 on the left, 1 on the right, and 1 in the middle. And the value is 7.888, and I see that right here, 7.888. That's it. That is the calculator portion. Okay, moving on. We're in the no calculator portion. And like, something I want to emphasize to you is just, please, like, do not use a calculator. Like, don't really practice not using a calculator. I'm still thinking of what I'm doing for the test in terms of like calculator usage, but do not use a calculator for any of these questions. Just do it by hand. Because regardless of whatever I do, in the AP test, this is no calculator. You cannot use one. Okay. Let's get started. 1, if y equals x squared sine 2x and dy dx is, so what is this? This is, I'm taking the derivative, and what is this? This is a product, so I want to use product rule. So it's going to be lefty right plus righty left. I'll write it out like nicely for you. Left f of x is 2x, and f prime of x, oh my god, sorry, f of x is x squared, f prime of x is 2x, g of x is sine 2x, and then g prime of x is cosine 2x times 2. Right, because this is a chain rule right here. Derivative of sine is cosine, and then keep the inside the same, then multiply by the derivative of the inside. Okay. Now we just do it in order, so it's going to be this times this times this times this. So it's going to be I'm going to kind of move the order of things around, but it's going to be 2x squared cosine 2x. That's me just combining those two. Plus 2x sine 2x. And since both of these have a common factor of 2x, I can take a 2x out. 2x comes out, and it'll be just x cosine 2x plus sine 2x. So I'll look at my answers over here. So definitely not these two. That doesn't make any sense. And I got 2x sine 2x was cosine. Nope, it's missing an x. This is a minus. That's a nope. So it's got to be e. And this is it. 2x sine 2x plus x cosine 2x. The only difference here is just the order, but it's fine. It's the same thing. Okay. 2. This is a quotient rule. Low d high minus high d low over low low. So low, my low is 2x plus 3, so it'll be 2x plus 3. D high, that's just 3, minus high, 3x minus 2. D low is just 2 over 2x plus 3 squared. Okay. We just have to simplify the numerator, and you can see all the denominators here are 2x plus 3 squared. We just have to make sure we simplify this accurately. So I'm going to distribute the 3. I'm going to get 6x plus 9 minus 6x. I'm just going to distribute this 6x. You know, I'll do it one step at a time. It's going to be 6x plus 9 minus 6x minus 4. Right, I just distributed the 2 there. And then I'm going to distribute this this negative. So this negative gets distributed here and here. And that'll get me 6x plus 9 minus 6x plus 4. Yeah. So that will be, the 6x's will cancel. Right, these two will cancel. And I'll just have 9 plus 4. 9 plus 4 is 13. So my answer is 13 over 2x plus 3 squared. Right, this is the final answer. 13 plus 2x plus 3 squared. D. Okay. 3. So these first two, very straightforward. B, expect to see questions like these, especially chain and quotient rule, just like those, and product. 3, this is a nice question. The graphs of two differential functions f and g are shown above. If p of x equals f of x times g of x, which is the following statements of p prime of negative 2 is true. I like this question a lot, because I think it kind of makes you think about product rule in a way that's different than just plugging. So if it wants me to find p prime of negative 2, first thing you want to do here is just like, okay, what is p prime of x? And this is literally just a product rule. So it's just going to be f of x times g prime of x plus f prime of x times g of x. And then I'm going to plug in a negative 2, p prime of negative 2 equals f of negative 2 g prime negative 2 plus f prime negative 2 g prime negative 2. Okay, and you might be thinking, oh well, I don't really have values here, right? I don't know what those are. Like I can't really see. That's okay. You don't need to, because you're only asking like what is the sign of it. So what's f of negative 2? Well, f of negative 2, we will look at f of negative 2 right here. It's 0. This is just 0. So I already know this one's going to end up 0, but g prime of negative 2 right here, it's just some positive number. So it's 0 times some positive number plus f prime of negative 2. F, the derivative at negative 2 is some positive number. positive number, times g of negative 2, not the derivative, just g of negative 2, is some negative number, right? Some negative number down here. So it's 0 times some positive number plus a positive number times a negative number. This is just going to be 0. And this is going to be some negative value. Okay? So it must be negative. Okay? So p prime of negative 2 must be less than 0. So this is just to recap that. This is just product rule. It's just product rule. This is a little mistake here. This just should be g of negative 2. You plug in the values. You plug in like the symbols. You go see like what they are. You don't need to know the numbers. You should know their signs. And from the signs, I saw, okay, well that must be 0, and this is a positive times a negative. You just have to know what they are. So derivative of tan x is secant squared. This is secant squared. Minus derivative of cotangent x is negative cosecant squared x. Easy. So it's double negative, so it's going to be a positive. So it's going to be secant squared x plus cosecant squared x is this one right here. It's e. That's it. Moving on, let f be a function given by f of x equals 2x minus 1 to the fifth times x plus 1, which of the following is an equation for the line tangent to f at the point where x equals 1. So key, and I've been saying this so many times. Equation for the line tangent. If you ever see those words, what do you do, guys? What do? You should be saying it right now. You write the equation of the tangent line. And what is that? And I want you to write it. Equation of the tangent line. Y minus y1 equals mx minus x1. You've been doing this since unit 2. It doesn't go anywhere. It keeps coming back over and over again. And now you just need to identify, again, what is your x1, your y1, and your m. Right? That's the goal. x1's given to you. There will always be some value given to you. That's just a 1. Okay? y1, I'm going to get my y1 by taking that x and plugging it in here. So I'm just going to find, I'll do it above here actually, f of 1 equals 2 minus 1 to the fifth times 1 plus 1. So that's just 1 times 2. It's 2. So y1 is 2. Last step is the m. I need the slope. So to get the slope, I have to, this is where the challenge is here, is that I have to take the derivative of f of x. So we'll do that down here. F prime of x. So what's f prime of x? This is product rule. Left d right plus right d left. So f prime of x is going to be left 2x minus 1 to the fifth. D right, that's just 1. Derivative of x is just 1. So just, I'll put in a 1 as a placeholder so you know that. Plus right, x plus 1. D left, derivative of the left is 5 parentheses 2x minus 1 to the fourth times 2. That's a chain rule right there. Because it's, I differentiated the outside, the 5 came down, minus 1 became the 4. And then the derivative of the inside was 2. 2x minus 1, like the derivative of that is 2. So I can like, I mean, I can kind of leave this as it is, but then I need to find the derivative at 1. So for f prime of 1, I'm just going to plug in a 1 into all of these. Okay, so 1 minus 1, so that's just a 1. So I have 1 times 1 plus, this is going to be a 2. 2 times 5. Again, it's another 1 times 2. Just plugging in. All I did here in this step was I just plugged in 1 for all the x's here, right? 1 minus 2 minus 1 is 1. 1 to the fifth is still 1. 1 is 1. 1 plus 1 is 2. 5 is 5. 2 minus 1 is 1. 1 to the fourth is still 1. and that's a 2. Now I could just combine. That's 10, 10, 20, 2. So f prime of 1 is 22. Sorry, 21. That's 1 plus 10 times 2 is 20. So it's f prime of 1 is 21. So this is m is 21. Now I just plug it in. Back to this formula. So it's going to be y minus 2 equals 21, x minus 1. I got to distribute things a little bit here because the way it's written is not written in my form. It's written with y alone. So I just have to move that 2 over basically. It's going to be y minus 2 equals 21x minus 21. Then I'm going to add the 2 over. Right, do that. I'll show you what I'm doing. Plus 2 plus 2. I will get y equals 21x minus 19. So my answer is B. So this question, I think it's definitely, it's a bit more tricky than the first couple, but it's, you know how to do this. You see equation of the tangent line, you write the equation of the tangent line, you identify x1, y1. x1 is usually given to you, y1 you get by plugging it in, and then m you get by taking the derivative, and I had to use a product rule there, then plugging in 1, and then writing out the equation and reorganizing it, and then you get B. Okay? 6. This should look a little familiar to you. This limit notation basically just means find the derivative of f of x at that point. This is point definition of the derivative. This just means find the derivative of this at this value. Okay, so I want, I'm basically, my f of x equals secant x. So I'm just finding the derivative of that. Derivative of secant is secant x tan x. So then f prime of pi over 3, I'm just going to plug in a pi over 3. Secant pi over 3, tan pi over 3. And so that's a C. Like when you see these problems, don't worry. Don't freak out about it. This just means really find the derivative of that at that value. That's all it means. So just know the derivative, again, know the derivative of the trig values. Okay, 7. The table above gives values of differentiable functions f and g and the derivatives at selected values of x. If h is a function defined by h of x equals f of x, g of x plus 2g of x, find h prime of 1. Very similar to other problems. You first want to do it symbolically, so I'm just going to write out what is the derivative of x. So h of x. Derivative of h of x is going to be, it's going to be product rule right here. So it's just f of x, g prime of x, plus g of x, f prime of x, then plus, this is no product or chain rule, it's just 2g prime of x. So this is what I mean by like taking the derivative symbolically. I'm not taking derivatives like of specific equations. I'm just taking derivatives of functions, and I know that I'm using product rule because this is multiplication. So whenever you see like things being multiplied, you know, okay, I got to use the product rule for that. F g prime plus g f prime. And this 2g of x is just, there's no rule there. I'm just taking the derivative of the g, and the 2 stays because it's a multiplier. Then let's sub in the 1. H prime of 1 will be f of 1 g prime of 1 plus g of 1 f prime of 1 plus 2g prime of 1. And this is similar to the delta where you're just plugging in the values, and they're given to you in the table up here. So f of 1 is 2, g prime of 1 is 3, so it's 2 times 3, g of 1 is -5, f prime of 1 is -4, plus 2 times g prime of 1, g prime of 1 is 3. So it's just plus 2 times 3. Right. All I do is pull them from the tables. I never once used this bottom row. I guess it put that there to confuse you because there's a 2 there. So like, oh, maybe you're like thinking, oh, like you have to use the 2. But you don't. That just means 2 times the derivative of g prime of 1. I never ever had to use the 2. So it says, so 6 plus 20 plus 6. So that's 32. So it's A. Okay, keep going. 8. This one might be tricky because the lines didn't print properly, but I'll do my best. The graphs of the linear function f and the linear function g are shown in the figure above. If h of x equals f of x g of x, what is h prime of 4? So it's the same thing, what we just did. I gotta find the derivative of h of x, right? So the derivative of h of x is just f of x, g prime of x, plus g of x, f prime of x, right? And then I'm going to plug in a 4. H prime of 4 equals f of 4, g prime of 4, plus g of 4, f prime of 4. And now I'm going to go find them. So f of 4 is right here. I'll mark it. F of 4 is 2. So f of 4 is just 2. G of 4, I'm going to do this one next. G of 4 is, sorry, this is G, it's just 1. So it's just 1. And then I need the derivative of G at 4. So again, to get derivative, you want to like make a triangle. There we go. That's it. You want to make a triangle between 2 points. So you can see this is 2 over, and then 1, 2, 3 up. It's 3 over 2. So the derivative of g prime at 4 is 3 over 2. Put that plus in there. So then f prime of 4 is the slope of 4, slope of f rather, at 4. And since the line is always the same, and you can actually see it's going up 1 over 1 here. It's 1 and 1. It's just 1 over 1. There's no shame in drawing out the triangle. Like, there's no shame in that. That's totally fine. Do not worry about that. So now we'll simplify. This is just 3 plus 1 is 4. So my answer is D, 4. All right, number 9. G of x equals x squared root x plus 1, then g prime of 3 equals. Okay, so product rule, very clearly. So it's going to be, you don't have to do it. I'll do it today. I'll do it for this one rather. F of x equals x squared. F prime of x equals 2x. G of x equals root x plus 1. G prime of x. Okay. So what's the derivative of this? So remember, this is the same as x plus 1 to the 1/2. So g prime of x is 1/2 x plus 1 to the negative 1/2. And yeah, that you can see kind of there's a chain rule here because the function inside, but the derivative of the inside is just 1. So I don't have to worry about this at all. Okay? They don't have to worry about multiplying the derivative of that because it's just 1. So let's combine. So we're going to get, I'm going to do it over here. We're going to have x squared times 1/2 x plus 1 to the negative 1/2 plus 2x times root x plus 1. And now I'm just going to plug in a 3 into that. So 3 is going to go in. So when I plug in a 3, I'll do it one at a time here. 2 times 3, that's 6, right? 3 plus 1 is 4. Root 4 is just 2. So at 2, I got 6. 3 squared is just 9. Okay, then let's do this one. This is 3 plus 1 is 4. 4 to the negative 1/2. Okay, I'm gonna kind of do this one over 2 steps so you know what's going on. I'm gonna rewrite this. This this expression really means 1 over 2 x plus 1 root. That is what this expression in blue, this right here, this really means this in blue. So when I plug 3 into that, I'm going to get 1 over 2 times, it's 3 going in, so 3 plus 1, root 3 plus 1 is just 2, so it's 1 over 4. So what I have is 9 times 1 over 4 plus 6 times 2. I hope that made sense. So basically, like, the steps here is you're doing product rule. So I found the functions and derivatives. I put them into the right order. Then I plugged in a 3, and the 9, 6, and 2 are really easy. This one is a little bit more tricky because that negative exponent might be tripping you up a little bit. But so I rewrote it so you understand what it means. This basically just gets moved in the denominator and you're square rooting it. That's what that 1/2 represents. That negative 1/2 is like you're square rooting it, but it's in the denominator. And when you plug in a 3 now, you get 1/4. So now I'm going to have 9/4 plus 12. Okay, and then to combine this, I have to write this 12 as a fraction over 4. So I can just multiply 12. If you think about it, this is 12 over 1, right? So I'm going to multiply top and bottom by 4 over 4. And that's going to get me 48 over 4. 9 plus 4. That's 9 over 4 plus 48 over 4. That is 57 over 4. Okay, so the 9/4 just stays. This is just simplifying a fraction. 12 over 12 is the same as 48 over 4. And I had to put it over 4 so I could add it with 9 over 4. That's how I got 57 over 4. This right here, the multiple by 4 over 4, is like an extra step to do that. Okay, but I'm allowed to do that because that's just 1. 4 over 4 is just 1. Okay, coming to office hours if that one did not make sense. 10. If f of x equals cosine cubed for x, then what is the derivative of that? This one is just chain rule. There's no product rule going on here because there's no multiplication. Reminder that this is the same as saying cosine 4x all to the third. When you have that third there, that really means this. So what we do first is we address the 3 first. So it's going to be 3 cosine squared 4x. Then my next one is the cosine. So then it's going to be times negative sine 4x. Then on the inside of that is the 4x, so it's then a times 4. So then when you kind of distribute everything out, see I have I'll show you what I'm doing. There's a negative here, there's a 4 here, and there's a 3 here. So when you put those all together, you're going to get negative 12. Cosine squared 4x sine 4x, and that is right here. It's b. Okay, so this is a chain rule problem. Chain rule. Okay, let's keep going. 11. We got more chain rule. More chain rule. Just gives you a function, find the derivative. What's the outside? The outside is the 5, so 5 comes first. 5, keep the inside the same, x cubed minus cosine x to the 4th. Now times the derivative of the inside. The derivative of the inside is just 3x squared plus sine x. So again, that is because the derivative of cosine is negative sine. So a double negative makes it a positive because it's already a minus cosine. So it's going to become a plus sine. So here I see that right here, e. Okay. 12. If f of x equals x squared minus 4 and g is differential function of x, what is the derivative f of g of x? So all this means is you're going to take g and plug it in for x. So instead of it being x squared minus 4, it's going to be g of x squared minus 4. That's it. And now we're going to take the derivative of that. So it's going to be 2 g of x times the derivative of the inside, g prime of x. That's it. The 4 goes away because it's just derivative of a constant, which is 0. So it's going to be d. All right. Next one. If f prime of x equals x I want to say that's a minus. I'm going to assume that's a minus. Sorry, guys. I'll make sure this is very clear on the test. X minus 2 squared, x squared minus 4. What is, and g of x equals f of x squared minus 1. What is g prime of 2? Okay. So, good to write it out. G prime of x equals my outside function derivative, which is f prime, x squared minus 1 times the derivative of the inside is just 2x. So then g prime of 2 will be f prime of 2 squared minus 1 is just 3 times 6. Okay. So I just need to find f prime of 3. So I'm going to take a 3, I'm going to plug it into here. 3 minus 2 is, this is just a 1 right here. Then I'm going to have 9 minus 4 is 5. So this is 1 times 5 over 16. It's 5 over 16. So it's 5 over 16 times 6. That's 30 over 6. Can I simplify that? Sorry, it's 30 over 16. Can I simplify that? Yes. That's the same as 15 over okay, I caught my mistake here. The mistake is back here. G prime of 2, that is 3, but 2 times 2 is not 6. This should be a 4. So this would change this to a 4, which means that it would not be 30 over 16. It would be 20 over 16, which is, when you divide top and bottom by 4, 5 over 4. So it is B. Okay, sorry about that. Yeah, just be super careful. What I did is I think I saw that 3 and I was like, oh yeah, 3 is just gonna go, I'm just gonna pop a 3 into that. But no, you're always popping this into this. Always, whatever's going to G prime is gonna go into the X here. 14. If f of x equals x squared minus 2x minus 1 to the 2/3, what is f prime of 0? So just gonna take the derivative. So it's gonna be 2/3. This is power rule right now. X squared minus 2x minus 1 to the negative 1/3, because 2/3 minus 1 is negative 1/3. Then times the derivative of the inside, which is just 2x minus 2. Then, so this is f prime of x. Then we're going to plug in a 0. And we're going to get, let's do this first. So it's going to be 0 minus 2, this is just negative 2. And then right here, I'm going to get 2/3 times 0, 0, negative 1 to the negative 1/3. So let's see here, this is negative 1 to the negative 1/3 times 2/3. So what's negative 1 to the negative 1/3? That is the same as 1 over the cube root of negative 1. That is what that's saying. That's what the negative 1/3 means. It means 1 over this number cube rooted. The cube root of negative 1 is just negative 1. So it's 2/3, oh my god, 2/3 times negative 1 times negative 2. So that's 2, oh my god, 2 times 2/3, which is 4/3. That is the answer, 4/3 A. Okay, we are moving kind of away from chain rule and into some of the other applications. We have a few more. Sorry, we have a few more. We're on 15 here. So this is something to be familiar with, is this notation. So this is not saying the first derivative. I just be very, very clear that this is the second derivative. So once again, like d square y over dx squared means second. And then if you see the third, that's, and so on, right? So this is saying take the second derivative of this. So we're going to take the derivative of this twice. The derivative of this twice means, okay, so the negative 3 is going to stay. The derivative of cosine is negative sine 2x, then times 2, because it's chain rule. Let's simplify that. That's going to be 2 negatives make a positive, so it's going to be 6 sine 2x. This is y prime. And then I feel like I need to be better at using these colors. I have colors, but am I actually using them well? I don't know. Y double prime would be 6, but now it's going to be cosine 2x times 2. And so that's going to get you 12 cosine 2x b. Okay, so that just means take the derivative twice. That's it. Okay, this one we have another chain rule. What's a chain rule today? So we've got 5x squared minus 7 all to the 1/3. That's, I'm just rewriting it so I can take the derivative nicely. This is f of x. Let's say the derivative. Derivative is going to be 1/3, keep the inside the same, 5x squared minus 7 to the negative 2/3 now, times the derivative of the inside, which is 10x. So combining like terms, or not combining like terms, you just put that 10x on top of the 1. 10x over 3, 5x squared minus 7 to the negative 2/3. Done. So I'm just going to look for that. 10x over 3, there you go, it's A. Okay, that is a chain rule. Okay, now we are kind of moving on from the chain product rules to, and as you can see, like that was half the test. Half the test was basically chain product quotient type questions, and that's more or less what you can expect from the test. Like a lot of these kinds of problems, and the delta is great practice for that, as is this test, right? Okay, we got L'Hopital's rule now. So yeah, I'm gonna take the time to write this out as you should write it. So I can see when I plug in a 0 here, I'm gonna get 0 over 0. The way that you do this on an FRQ, I'll show you how to do it. On an FRQ, you're gonna say limit x approaches 0, x squared is 0, and you're gonna say limit x approaches 0, 1 minus cosine x is 0, and that's because cosine of 0 is 1. So since both of these are this, then you have 0 over 0, which is indeterminate, which means I can use L'Hopital's. Okay, which means now I can take the derivative of top and bottom. So I can now do limit x approaches 0, 2x over 1 plus sine, sorry, just sine x. There's no 1. Sorry, I am not doing the best job this time. 2x over sine x. Now plug in 0 again. Now you're going to get 0 on top. And you're still going to get 0 on the bottom. So you do it again. You got to do it again. So you would say, if this is an FRQ, you would basically show this again. Because I'm getting 0 over 0 again, do it again. So it's going to be now 2 over negative cosine x. Now plug in a 0 again, is 2 over negative 1. It's 2 over negative 1, so it's negative 2. This is a funny one because you do it twice. So this top part here is kind of like, this is the work, FRQ work. If this was like in an FRQ, you have to show it this way. You take the limit top, limit at the bottom, 0, 0, indeterminate, L'Hopital's, then you take derivative, then you do it again. And if it comes out 0, 0 again, you have to show this work again. On multiple choice, I'm not going to be strict about that. If you get the right answer, you get the right answer. If you don't do it this way, that's totally fine. But on FRQ, I expect you to do it the right way. And then the key difference with this problem is, okay, we got 0 over 0 again. I'm going to kind of mark that here. This is 0 over 0, which means we do it again. You take the derivative again, 2 over negative cosine x. And then finally you get 2 over negative 1, negative 2. All right. Let g be a continuously differentiable function where g of 1 is 6, g prime of 1 is 3. What is the limit? It's 1, integral 1 to x, g of t dt over g of x minus 6. And this like might freak you out. Like oh my god, I've never seen anything like this before. But you know, you can do this. The first thing you do is you just plug in a 1. So when I plug in a 1 into this, I'm going to get integral 1 to 1 g of t dt over g of 1 minus 6. Well, what's the any integral from the same bounds is 0, right? So that's just 0. And then g of 1 is 6, so 6 minus 6, that's also 0. So this is L'Hopital's rule. So same thing, if this is an FRQ, you show it the work this way. For the sake of this and for the sake of space, I'm not going to do that. We're now going to take the derivative of top and bottom. So we do that right here. What is the derivative of the integral 1 to x g of t dt? That's just g of x. That's fundamental theorem of calculus. That's just g of x. And then at the bottom, right, the derivative of that is just g of x. At the bottom, I'm just going to have g prime of x. Now let's plug in a 1. Plug in a 1 into this. G prime of 1 is 3. G of 1 is 6. Oh my god. G of 1 is 6 over G prime of 1 is 3. 6 divided by 3 is 2. Okay, I'll review this one, right? First thing you do, when you have a limit, always, you just take this 1 and it goes in for the x's here and here. That's what you do. That's what I did right here. Put in a 1, put in a 1. I got 0 over 0. When you get 0 over 0, that's indeterminate, you do L'Hopital's rule. You take the derivative of the top, the derivative of the bottom. The derivative of 1 of the x, g of t dt, is just g of x. That's fundamental theorem of calculus. So we talked about last class, the last class of this unit. We talked about that a little bit. Derivative of the bottom is just g prime of x, and the 6 goes away. So then I have g of x over g prime of x. Then I plug in a 1 into both of those. G of 1 tells me is 6. G prime of 1, it tells me is 3. 6 over 3. 6 over 3 is 2. Answer is 2. That's it. Okay? All right, moving on. 19. Let f be a differential function with f of 2 equals 3. F prime of 2 is 1/2. Use the line tangent to the graph of f at 2 as a local linear approximation of f. What is the estimate of 1.8? Look, line tangent. This should be really, this is that key that I was telling you about. Whenever you see that, what do? You write out your formula. Y minus y1 equals mx minus x1. And this is nice enough to give us the points we need, because my x1 is right here is 2. It tells me x1 is 2. My y1 is right here. y1 is 3. So this is x1, this is y1. And then it's so kind to give us the m. I don't have to find the m. Sorry, it tells me the m right here. M equals 1/2. So I've got all my points. I'll make my formula. It's going to be y minus 3 equals 1/2 x minus 2. And then I'm just going to plug in a 1.8 into that. That's what I'm doing. So I can just rewrite it again. Y minus 3 equals 1/2. But instead of x, I'm going to write a 1.8 minus 2. Okay. Let's do this. What's half of 1.8? That's 1.8 minus 2. Let's do that first. Negative 0.2. Oh, geez. Negative 0.2. 1/2 times that. Okay. Y minus 3 equals that. 1/2 of negative 0.2 is just negative 0.1. Right? Y minus 3 equals negative 0.1, then I'll just do plus 3, so y equals 2.9. That is it. C. Okay, got it? So you make your equation, you make your tangent line equation, which oftentimes this just gives you the values for, not always, but oftentimes it'll just give them to you. You make your equation, you plug in your new value, 1.8, you evaluate it, you get 2.9. Okay. 20. Select the values of the derivative of the function g or above table. Let us know that g of 4 equals 12. What is the approximation of g of 4.2 using the line tangent to the graph of g? Again, line tangent. That should tell you immediately what I've been saying. Y minus y1 equals mx minus x1. Always write it down. Just write it. Right? It'll help you. It'll give you structure. It'll tell you where to go. Right? And same thing. All the values are given to you here. x1. That's my x1 right here. x1 is 4. It tells me that g of 4 is 12, so y1 must be 12. And then this table is going to help me find the derivative. So I want the derivative at 4. So I'm going to go to 4. This is derivative, right? Derivative at 4 is 2.2. So this right here is my m. Don't need to worry about these other values because I only care about 4, right? So my m is 2.2. Write the equation. It's going to be y minus 12 equals 2.2 times x minus 4, but I'm going to plug in a what? I'm going to plug in a 4.2. That's what's going in. So I'm going to rewrite it again. Y minus 12 equals 2.2 times 4.2 minus 4. Let's do it. So 4.2 minus 4 is just 0.2. So I'm going to come back over here. It's going to be y minus 12 equals 2.2 times 0.2. Okay, then we're going to multiply here. 2.2 times 0.2 is 0.44. 0.44. Right, because 2 times 2 is 4, right? And 0.2 times 0.2 is 0.04. That's why it's 0.44. Think about it like this. Like 22 times 2 is 44, right? So 2.2 times 2 must be 2.2 times 0.2 must be 0.44. Because I moved the decimal places 2 to the left here. I moved it 2 to the left here. That's the best way I can explain that. Y minus 12 equals that, so plus the 12 plus the 12, y equals 12.44. Okay. Now remember, no calculator, and I think this 2.2 is a place where you might be tempted to to use a calculator. You guys can do this. You can figure out what 2.2 times 0.2 is, and like something to look at here is look at the options. So like even if let's just say hypothetically you couldn't do that, right? You couldn't do 2.2 times 0.2, you couldn't figure that out. You can still look at your options and figure it out from this, right? Because you know that like, okay, it can't be 11.6 because you're adding the 12. That's not even possible. I mean, 12.4 doesn't make any sense because that would be 2 times 0.2. You can figure that out, right? And so 0.3 doesn't make any sense because that's less than that. So it has to be 12.44. So if you come across like a tough arithmetic thing that you're like, oh, I don't really know how to do that. I don't remember how to do that. Just kind of look at the answers to help you figure out which one makes sense. So don't give up. Always look at the answers to help you as well. All right, 21. Let g be a differential function such as g of 3 is 2, g prime of 3 is negative 3/4. A graph of g is concave down on an interval 2 to 4. Which of the following is true by the approximation of 2.6 using line tangent to the graph? Okay, same thing. 3 questions, all the same. Y minus y1 equals m. X minus x1. Let's label them. What are y1, x1, and m? Let's see here. Well, it says tangent to 3, so x1 must be 3. It tells me that g of 3 is 2, so y1 is 2. It tells me the derivative is negative 3/4, so my m is negative 3/4. Let's make it. So it's going to be y minus 2 equals negative 3/4 x minus 3. We're going to plug in a 2.6. So we're going to get y minus 2 equals negative 3/4. 2.6 minus 3. Minus 3. Let's do it. 2.6 minus 3 is negative 0.4. I'm going to write that as 2/5. negative 2/5. That's negative 2/5. Okay, how do I do that? 2.6 minus 3 is negative 0.4, right? That's negative 0.4. I'm going to do it down here. Negative 0.4. That's the same as 4 over 10. That's the same as 2/5, right? Negative 4 over 10, negative 2/5. The reason I'm doing that is because I see I'm about to multiply by a fraction, and it's going to be a lot easier to deal with. It's going to be easier to deal with the fractions than trying to multiply the decimals. That's why I converted it to a fraction here. So okay, now we're going to kind of simplify this a little bit. 3/4 times, I'm just going to bring this down here, guys. I might have to just get extra paper, but it's fine. Y minus 2 equals negative 3/4 times negative 2/5. And we just multiply across here. So you get 6 over 20 there. Y minus 2 equals 6 over 20. Now 6 over 20 is just 3 over 10, right? So 3 over 10 is just 0.3. So I'm going to add the 2, both sides, plus 2, plus 2. And then I'm going to get y equals 2.3. So there was some fraction-y things going on here, right? It is one of these 2.3s. Let me refresh that one more time. So I think you guys are all probably good in the first part. So it's like, okay, find your y1 and x1, plug them in. Good. Get your equation. Plug in your value, which is 2.6. Then I think this is where some of you might be getting like stuck, because you're gonna get like 0.4 times negative 3/4, and it's just a bit messy. And maybe you could probably figure that out in decimals, but I find it's easier to do in fractions. So I changed that negative 0.4 to be negative 2/5, so I could multiply the fractions. 3 times 2 is 6, or negative 3 times negative 2 is 6. 4 times 5 is 20. 6 over 20 is 3 over 10, which is 0.3, right? So that's 0.3. So really this is just 0.3 plus 2. 0.32 plus 2 is 2.3. That's how I know it's one of these 2.3s, okay? So then this other question is it an over approximation or is it an over approximation? And that's given to you by this concave down. So when it's concave down, you can just draw a picture to look at it. That's concave down, right? If you draw any line here, any line on concave down, right? It's always above. No matter where I draw it, I could draw it there, I could draw it there, right? It's always above the line. So it's going to be an overestimate. The answer is C. Okay. 22. Let f be the function given by fx equals x to the third minus 6x squared minus 15x. What is the maximum value of f on the interval 0 to 6? I am going to need paper for this. All right, guys. Okay, so 23, and that's another absolute problem. I've done this one, I've looked into it, and I know this is a no calculator one, and I said, oh, do not use a calculator in this. I'm making an exception. This problem is one that I believe should be a calculator problem. They're saying it's no calculator, and I'm not saying that they would not give you something like this. I will not give you something like this without a calculator. And you can do this without a calculator, but it's a lot of arithmetic, and I think it's just going to kind of overcomplicate things for you, and I'm not going to do that. So to avoid that entirely, I'm going to do this with some help of the calculator, but I'm still going to walk you through all the processes of it. Okay, and I just want you to know that on the test, like, I'm never going to give you something like a non-calculator question that is this tedious or that cannot be done with a calculator. Okay, cannot be done without a calculator, or like would take you a lot of time, right? So important to know here is that this is when x equals a certain value. Okay, what is the value that x needs to equal? What's our goal? So candidates test, we're trying to find the maximum. So candidates are always the endpoints. The endpoints are 0 and 9, and the candidates, we need to find those. So we're going to take the derivative, f prime of x equals x squared minus 8x plus 12. Two numbers that multiply to 12 to get negative 8 are x minus 6 and x minus 2. So my candidates are, critical points are x equals 6 and x equals 2. Both of these are going to count because they're both within 0 and 9, so all of them go in. So I have 0, 9, 6, and 2. These two are my endpoints, my EPs, and then these two are my critical points, CPs. And this is where the really tedious part is that I'm not going to make you do. So 0 is easy. When you plug in a 0 into the original function, let's go up here. You plug in 0 into the original function, you just get -5 because all those go into zeros. However, you'll notice if you plug a 9 into this, you're going to have a 9 to the third times 1/3. That like expression itself takes a lot of working out to do. And so we're not going to do that. I'm going to go to y equals, and I'm going to put in my function. So I'm going to put in 1/3 x math 3 minus 4x squared plus 12x minus 5. And I'm just going to plug in to my y1. I mean, I'll test the 0 to make sure I wrote it in right. Yep, I get -5. Let's plug in the 9. I get 22. So 9 is 22. 6 is -5. And then 2 is 5 and 2/3. So you can see my my maximum is 22, which happens at 9. So the answer is 9. So the steps are exactly the same. You have your EPs, you have your critical points, you find both of them, you put them in the chart, and you evaluate them. In the test, if it's a non-calculated question, it will be relatively easy to plug these values into this equation. In this case, because it was so tedious to put these in and do this by hand, we used the calculator. And I just plugged them into the calculator, I got the values, and then I identified the maximum, this is the max, which happens at 9, so the answer is 9. Okay, moving on. All right, let f be a twice differentiable function, which of the following is individual sufficient to conclude that x equals 2 is the absolute maximum of f on the interval -5, 5. Okay. So this is just saying that it's a critical point, and that is definitely not enough. That's nowhere near enough. Any point can be 0. A critical point is of 0, but like that doesn't mean that it could be a max, it could be a min, it could be many things. So that's absolutely just not enough. The second one says it's the only critical point of f from -5 to 5, and it's concave down. So this is telling you, this is from the notes, that if it's concave down and it's a critical point, it must be, if you picture it, it must be a relative max. So what this is saying, if this is the only critical point, then this is the only time that it changes, like from increasing to decreasing. That's key here. It's the only one, and it's changing from increasing to decreasing. And I know it's a relative max, like this tells me it's a relative max. Therefore, this is enough. 2 is enough, because there's no way it could ever be higher than this on the interval, because you know it's going to have to increase a bit, and it's going to be decreasing after. Okay. The other one says it's a critical point, and that it's the only critical point, and that the starting is less than the ending is less than f of 2. This is also enough. What it's saying is it's the only critical point, meaning that either it's going to be, it doesn't tell me if it's relative max or relative min, but this like implies that it must be, because it's saying that f of -5 is lower than f of 5. So you picture this is f of -5, this is 5, and it's saying that f of 2 is higher than all of them. Right? If you look at this, you can see, and it's the only critical point, which means that it's only changing directions one time in this entire interval. So like this right here is f of -5, right? This is f of 5, and this is f of 2. So it means that, okay, it has to go up, and it's the critical point, it has to go down at that point. So this must be true. It must be the absolute max. So it's both 2 and 3. It's a D. Okay. 25. Let f be a twice differentiable function. Select values of f and f prime and f double prime are shown above, which of the following statements are true. F has neither relative max nor relative min at x equals 1. F has a relative maximum at x equals 1, f has a relative max when x equals 4. This is where the second derivative test is being applied. So remember, the second derivative test says that if f prime of x is 0, and if f double prime of x is less than 0, it's a relative max. Okay? If f prime of x is 0 and f prime of x is greater than 0, it's a relative min. Okay? So you're just like, you know this, and so use this as a key. And you don't need to worry really about the other values. So we're just going to go 1. And it says, so at 1, I'm at 0, it's a critical point, and it's negative. So since it's negative, it must be a relative max there. So 2 is true. 2 100% is true, 1 is false. It says f has a relative maximum at 4. Well, if you go to 4, its second derivative is positive. So positive would indicate it's a relative min. It is not a relative max. 2 only is true. Okay, so for these, you just look at the slice. Look at these slices, right? And you're saying, okay, it's 0, both of these. This one's negative. Second derivative says that if this is concave down like this, it has to be a relative max. This one is concave up, meaning it's like this, so it must be a relative min. I talk about this in the notes section a bit. So, all right, moving on. Okay, here we go. FRQ with calculator 2017, number 2. This is a rate in, rate out question. So this is what we did, I think it's the second day of the unit. Rate in, rate out. When a certain grocery store opens that has 50 pounds of bananas on a table, customers remove bananas from the table at a rate modeled by this function. Okay, so that's really key, remove. So it's like, okay, that's my rate out. Make sure like annotate as you read, right? That's my rate out, okay? And F of t is measured per pounds per hour, t is number of hours, okay. After the store has been open for 3 hours. Okay, that's kind of key. After the store has been open for 3 hours. So it's not happening immediately. It has to be open for 3 hours. Then we start to add them back. And that's modeled by that. So this is my rate in. Rate in is clearly the g of t, and then my rate out is f of t, where g of t is measured per pound per hour. Okay, good. So how many pounds of bananas are removed from the display table during the first 2 hours the store is open? Well, this should be good, guys. You should be great at this. This is just, remember, the integral of the rate is the quantity. So it says removed. So I don't care about the rate in. I'm only care about the rate out. So I'm just going to take the integral of from 0 to 2, because it's from the first 2 hours, right, of f of t dt. That's it. That's all you do. So I'm going to, we're going to have to put these in the calculator anyway, so I'm going to put them in. Really important to take note of which one's the rate in and which one's the rate out when you're putting in the calculator. And I'm just gonna get in that. I personally like just putting rate in y1 and rate out in y2. So I'm just gonna do that. So my y1, I'm gonna put g of t, my rate in, 3 plus 2.4 ln x squared plus 2x, done. That's from 3 to 12. And then in my y2, I'll put the rate out. So 10 plus 0.8 x sine parentheses x math 3 divided by 100. Close it. Okay, looks good. So then I'm going to go back to home and we're going to evaluate this. So it's math 9. And my rate out is in y2, so it's going to be vars, y vars function y2 comma x comma 0 comma 2. Okay, so it is 20.05. I'm going to route to 3 decimals, so 20.051. So we can say, let's write the nice sentence, 20.051 pounds of bananas were removed in the first 2 hours. Okay. All right, find f prime of 7 using correct units. Explain the meaning of f prime of 7 in the context of the problem. Okay, so we know what f of 7 is, so we know what f of t is. It gives us to us, and that's the rate out. So if we want f prime of 7, it's not just f of 7. We need to find the derivative of it. So again, like this right here is the derivative, so we need to do math 8. So I'm going to do math 8 vars, y vars function, y2 at 7, comma x, comma 7. And that gets me negative 8.120. Okay, so f prime of 7 equals negative 8.120. What does this mean? This means you have to be very specific here. So you see 7 hours, because that's key, 7 hours after the store is opened, the rate at which bananas are being removed is decreasing by 8.120 bananas per hour squared. Okay. So this is like the rate of a rate. It's like, it's almost, think of it almost like the second derivative. So this is not like how many bananas are being removed 7 hours after. It's the rate at which bananas are being removed is changing. So it's saying 7 hours after the store is opened, the rate at which bananas are being removed is decreasing by 8.120 bananas per hour squared. So this one, you get 1 point for getting that, you get 1 point for explaining it. Is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? Give a reason for your answer. So for this one, you need to see if more bananas are going in at that time or more bananas are going out. That's the idea. So it's the rate in minus the rate out at that time. So we're going to take the rate in, so g of 5, and subtract f of 5. Let's find what that is. So we can do the calculator. So we're going to do bars, y bar is rate in of 5 minus the rate out at 5 equals negative 2.263, negative 2.263, and that is less than 0, right? So because the rate in g of 5 minus f of 5 is less than 0, the number of bananas is decreasing at t equals 5. Okay. Last one. How many pounds of bananas are left on the table at t equals 8? This is like kind of the comprehensive question. This one's worth 3 points. So you need all the information. So we go back up to the top. We start with 50 pounds. I should have noted that at the beginning, but we have 50 to begin with. So we're going to start with 50. And then we are going to take away bananas from 0 to 12. That's really the key. So from 0 to 12 right here, we're taking away, so we're going to subtract the integral from 0 to 8 of f of t dt. And then we're going to add the integral of from 3 to 8 of g of t dt. And again, the reason that it's 3 to 8 and I have to separate these out is because it's only going in, starts going in at 3. So I can't integrate 0 to 3 of that. That's why it has to be two separate integrals like this. And in a way that this kind of makes it easy. This is the starting value, right? This is starting value. Then this is minus the quantity out. And then this is plus the quantity in. That's what's going on. So let's do it in the calculator. So we want math 9. This is rate out. Let's do that one first. So it's going to be y2, comma x, comma 0, comma 8 is loading. So what's going on right here? 85.617. I'll put it right below. This is 85.617, and then the same thing but for y2, sorry, y1 from 3 to 8. Let's see, I'm doing it here. Same thing for y1, but 3 to 8 is 58.964. 58.964. So we're going to do that plus the 50 minus the 85.617 is left with 23.347. 23.347 pounds. So 23 of bananas are on display at t equals 8. Okay, that's it. Let's rate in, rate out. Okay, here we go. This is the graph analysis one. So another common FRQ type is graph analysis, where they give you a graph and they're asking you questions about it. So the function f is defined as closed interval -2 to 8, satisfies that f of 2 equals 1. This is very important, right? The graph of f prime, the derivative of f, consists of two line segments in a semicircle. All right, semicircle as shown in the figure. So this is a circle here. It'll tell you it's a circle. If it's a parabola or equation, it'll tell you that. Does f have a relative min, relative max, or neither at x equals 6? Give a reason for your answer. So if we look at x equals 6 right here, we can see that the derivative, right? This is the derivative. That's key. We're looking at the derivative. The derivative does not cross over the x-axis. So remember, when it crosses over, I'll do some examples. When it crosses over like that, you have a max. This is a relative max, right? Because it's going from positive to negative. When it goes like this, you have a relative min. But when it doesn't cross over, you don't have either. You don't have relative max or relative min. So we can say that f has neither a relative max nor relative min because f prime of x does not change sign. Keep it simple. That's it. At x equals 6. That's very important. You have to mention the location, right? Okay, moving on. What intervals, if any, is f concave down? So this is kind of review, like where is it concave down? Well, it's concave down when either the second derivative is negative or the first derivative is decreasing. That's when it's concave down. So I'm not given the second derivative here, but I'm given the first derivative. So I'm just looking for where this is decreasing. So where is it decreasing? I see it's decreasing from negative to 0, and it's decreasing from 4 to 6. So my answer, I say, the graph of f, sorry, we just say f is concave down on negative 2, 0, and 4 to 6 because f prime of x is decreasing on those intervals. Okay, very, very important, guys, that when you're writing your answer, you have to be specific, and you can't say it is concave down. It's really important that you say f is concave down on here and here, because what? F prime of x is decreasing on those intervals. And that was like the biggest mistake I saw from last test, like you just not being specific about what you're talking about. All right. Now, same graph, same premise here, but now we have a limit. So what do you think this might be? This what we just learned, L'Hopital's rule. So first thing you do when you see L'Hopital's rule, it might not be L'Hopital's rule, but we're gonna assume it is. So usually limit questions on the AP test are L'Hopital's rule, or at least half of them are, especially on an FRQ like this. So we're gonna take the limit at the top, limit at the bottom. I'm gonna show you exactly the right way to write this out. So we're gonna say limit x approaches 2 of 6 f of x minus 3x equals, well, f of 2 is 1. It's given to us here. So when I plug it into it tells you, right? So it's just going to be 6 minus 6, which is 0. And then the limit x approaches 2 x squared minus 5x plus 6. That's going to equal 4 minus 10 plus 6, which is also 0. So now we can say here, because limit x approaches 2 of 6f of x minus 3x over x squared minus 5x plus 6 is 0 over 0 indeterminate. L'Hopital's rule can be applied. So using L'Hopital's rule, we're going to say limit x approaches 2, and then we're derivative. So we're going to get 6 f prime of x minus 3 over 2x minus 5. Let's plug in the 2 into that. F prime of 2, I have that, is 0. So 0 minus 3 is negative 3. You see that f prime of 2, I have f prime here, so f prime of 2 is just 0. So 6 minus 0 minus 3 is just negative 3, and then 4 minus 5 is negative 1, so negative 3 over negative 1, it is 3. So that is L'Hopital's rule in an FRQ, exactly how you're supposed to write it. You take the limit of the numerator and denominator separately. You say, okay, because the limit is 0, 0 or indeterminate, I can apply L'Hopital's rule. I apply L'Hopital's rule, and I get my answer, just like that. Okay, moving on to D. What's the absolute minimum of f from the closed interval negative 2, 8? Absolute. Whenever you see this, you're like, okay, that's candidates test. That's candidates, right? That's your hint. So let's set it up the table. X and f of x. My options are going to be the endpoints, which are negative 2 and 8. I'm just going to put 8 down here to make space for my other values. And then all of my critical values. So I need to say that. Like, I can't just go ahead and write them. I have to say, okay, where is f of prime of x equals 0? This is at x equals, and I'm going to look at the graph, negative 1, 2, and 6. So I have x equals negative 1, x equals 2, x equals 6. So these are going in. Negative 1, 2, 6. Got my candidates. I've got me considering the derivative equaling 0. And then now I need to find my values. Okay. So you're told that f of 2 is 1. That's given to you. F of 2 is 1. So I'm going to go ahead and write that one in. And then I can go find my other values. So back here, what are my other values going to be? So a reminder that f of 2 right here equals 1. So as I find these other points, I'm adding and subtracting areas, just like we did in that multiple choice problem. You're adding and subtracting the areas. So let's go to the left. Let's work to the left here. All this area here. What is that? That is a 2 by 1, 2, 3. So this is a minus 3 right here. So that means, but I'm going backwards, right? So really I'm adding 3. So when I change that to a plus 3, because I'm going backwards, right? I'm going 2 to negative 1. So I'm going to add 3. So at negative 1, I'm at 3. Sorry, I'm at 4, because I'm going to add 3 to 1. Then at negative 2, I'm adding so it's a 2 by 1, so it's 1. And you might think, oh, I'm adding 1, but because I'm going backwards, I'm subtracting 1. Because this direction is going backwards, right? Backwards. So, we're reverse, like where it's negative, we're actually adding. Where we're adding, we're actually subtracting. So that means at negative 2, I'm actually at 3. Okay. So remember, I'm looking for the minimum. So far, I've not found a minimum. And then I'm going to go to the right. So my next point is at 6 over here. So I have a 2 by 2 right here. So the area of this is this is a plus 2, and then I need the area of this section right here. So the area of this big circle, right? Remember, that's pi r squared over 2, and my r is 2. So this would be 4 pi over 2. Which is 2 pi. So this whole area here is 2 pi. But that means that this chunk right here is worth a pi, right? And this is a pi. But I don't want the pi. I want like this region that's left over. So the area of this region, this blue region here, is going to be this big square, which is a 2, which is 2 by 2, which is 4. This is 4 minus pi. So at 6 is going to be 1 plus the 2 is 3 plus the 4 is 7, but minus pi, it's 7 minus pi. And I can show you why that is again. So I'm at 1 right here. F of 2 is 1. And I'm adding the 2. And then I'm adding the 4, but I'm minusing the pi because to account for this pi region here. And then the last zone is at 8. This is the same, right? It's another this zone right here. All of this is another 4 minus pi. So I'm just going to add another one of those. So it's going to be 7 minus 2 pi. Sorry, 11 minus 2 pi. Okay, there are my candidates. Those are my values. The smallest of those is this one, right? Clearly it's 1 is the smallest. So I'd say my absolute minimum of f is f of 2 equals 1. So you really key here, the answer is 1. That is your absolute minimum. It happens at x equals 2, but the answer is 1. Okay? So again, anytime you see absolute max or min, you make your table, you put the endpoints on the table, you find your critical values, which is just where the derivative equals 0. And then you test all of them by finding them, either you're plugging them into an equation or you're finding them graphically using that starting value, the 1, and then you're just adding and subtracting the areas from where you begin. So it's 1, and when you're going backwards, you do the reverse. You're adding 3 here, and then you're subtracting 1 here. And when you go to the right, maybe I'll like make a note of that. This direction was forwards. So it's like normal, right? It's all based off of, I think also important, it's all based of this 1, this starting value, this SV, which is 1. So everything is, we begin at 1, and so we add 3 to 1 and subtract 1 from 1, and then as we go right, we add the 2, we add the 4, we add the negative pi, we add the 4, we add the negative pi. And that's it. Okay. Moving on. Last problem. Okay, this is the just do calculus kind of question. These are not like super common, I'd say. See, the other two I gave you, they're almost always on the AP test. This is a great question because it like, even though this isn't the most popular FRQ, it often appears on multiple choice. It's a great question, and I think most students kind of like this kind of question because it's familiar to them. You see a table with a whole bunch of values, f's and f primes, g and g primes. This is familiar from Delta probably, and you're doing different like chain and product rules on this table. So you're referring to these values. Let's look at A. Let h be the function defined by h of x equals f of g of x. Find h prime of 7. Show that works at least your answer. So for a great place to start here is just showing it symbolically. So this is chain rule. Like that should be very clear to you that this is just chain rule. This is f prime of g of x times g prime of x. Like if you're ever unsure where to start, just write it symbolically. Also really important here is that when there's an x here, there's an x here and here. So I'm gonna show this with colors on the next one. I'm gonna change this to h prime of 7 equals f prime g of g prime of, and then I'll add the 7s in. Just really important when they'll take off points for this, they'll take off points for it. If this does not match this, like you cannot mix the 7s and the x's. The 7s have to match with the 7s, x's have to match with the x's. Once you get to this point, then you're just plugging in. So you go pull the values. So h prime of 7 is, well, it's g prime of 7 is, I'm just gonna like write it off to the side. I think there's nothing wrong with just showing extra work. G prime of 7 is, so you just line it up, 7 and g prime is 8. G of 7, which I need, is 0. So I'm gonna rewrite this. This is the same as f prime of g of 0 times 8, right? I just kind of found my first layer. G prime of 7 is 8, g of 7 is 0. Well, I'm sorry. I am very sorry. This is just f prime of 0. That is just going, this 0 is just going inside of here. That's g of 7 is 0. Do not make my mistake I just made. 0 goes in here. I'm rewriting that again. I am so embarrassed by that. That's f prime of 0 times 8. Follow me? Because g of 7 is going inside of here. I wish I mean, I want to edit that out, but I'm not going to. 0 went in there. F prime of 0 times 8. F prime of 0 is 10. Nope. F prime of 0 is 3 halves. So I'm going to write that right here. F prime of 0 is 3/2. So this just equals 3/2 times 8. This is actually fine. You could write this 3/2 times 8. Let's just simplify it though. 3 times 8 is 24. 24 divided by 2 is 12. So the answer is 12. So we can say h prime of 7 equals 12. Again, not h prime of 8, not h prime of x, h prime of 7, and they're very, very different. Make sure that numbers match with numbers and x's match with x. Okay. Next one. Let k be a differential function such that k prime of x is f of x squared times g of x is the graph of k concave up or concave down where x equals 4. So concave up would indicate to us that k double prime of x is positive, and concave down would indicate to us that k double prime of x is negative. So we need to find k double prime of x. How do we do that? First, like we've been doing, write out the formula. So k double prime of x equals, it's lefty right plus righty left, right? It's going to be left f of x squared g prime of x plus derivative of the left 2 f of x f prime of x g of x. So let me just make sure that's clear. That is the left, my left, f of x squared. That is the derivative of the left right here. It's changed to f of x, f prime of x. That's the derivative, okay? And then my right is g of x. So d right is g prime of x, g of x is just my right. Now, write it again, but plug in the 4. We have f of 4 squared g prime of 4 plus 2f of 4 f prime of 4 g of 4. Okay, and no shame in taking your time and just writing it out so you don't make a mistake. F of 4, I need to know that, so let's write them up here. Let's write out all the values I need to know. F of 4 is, line it up, is 4. G prime of 4, I need that. That is 2. Then I need f of 4. I already have a 4 is 4. I need f of prime of 4 as well. F prime of 4 is 3. And I also need regular g of 4, which is negative 3. Okay, now I'm just plugging them in. So f of 4 squared, that is 4 squared, that is 16. That is 16 times g prime of 4 was 2. Then plus f of 4 is, so it's 2 times f of 4 was 4 times f prime of 4 was 3 times negative 3, and this comes out to, if we say about 16 times 2 is 32, and then 2 times 4 is 8, 8 times 3 is 24, 24 times negative 3 is negative 72, so it's minus 72, which is negative 40. Okay, so you can say, do it over here in this corner, k prime of 4 equals negative 40, which is less than 0. Therefore, k is concave down at x equals 4. because k double prime of 4 is less than 0. I kind of repeated myself twice there. I'm just doing it to be clear. It's concave down because the second derivative is negative. Let m be a function defined by m of x equals 5x to the third plus the integral of 0 to x f prime of t dt. Find m of 2. Show the word that leads to your answer. So don't freak out when you see this. Like when you find m of 2, all you're doing is plugging in a 2 into this. So we're going to get 5 2 to the third plus the integral of 0 to 2 f prime of t dt. Okay, so what's this? 8 times 5, this is just 40 here. And then this is fundamental theorem of calculus. So it's going to be the antiderivative of f prime, which is, so it's going to be just, in parentheses here, f of 2 minus f of 0. Do you understand why I did that? That is just fundamental theorem of calculus. It's part 2. It's saying that the integral, definite integral of some function is the antiderivative of that function, which in this case is f, of the top minus the bottom. Okay, that's a review from last unit. And that comes out to, if we look at what is f of 2 is 7, f of 0 is 10, so it's 40 plus 7 minus 10, which is negative 3. So that's going to equal 37. Okay. Last one is the rate, is the function m defined in part C increasing, decreasing, or neither at 2. So we need to find the derivative. If I want to know if it's increasing or decreasing, I need to know about the derivative. Is the derivative positive or negative? So we're going to take the derivative of x. M prime of x is going to be, take the derivative. That's going to be 15x squared. And then this is fundamental theorem of calculus. This is just plus f prime of x, because that's fundamental theorem of calculus. The derivative of an integral from 0 to some, or from a number to some variable, is just the inside function, which is f prime of x. Not f double prime of x, not f of x, it's f prime of x. It's what's on the inside. Then plug in a 2. Derivative at 2 is 4 times 15 is 60 plus f prime of 2. F prime of 2 is given to us to be negative 8. So it's 60 minus 8, which is 52, which means, since it's positive, m is increasing at x equals 2 because m prime of 2 is greater than 0. You could say like 52 is greater than 0, right, as well. Okay. Okay, I'm gonna do the extra practice as well. Again, this is extra practice. I would say that the first part, that's plenty, you know, having just completed everything. Like, that's a lot. This is just like, okay, I've done everything. I've done it again. I've done the practice test. I'm like, I don't know what else to do. This is for you, right? This is for you. Like, you've done everything. You just want some more problems. And I assume if you're entering this, you've already done everything else. So really, you should be doing these, trying to do these without my help, and then checking your answers. So use the extra practice as like another resource for you. Okay, here we go. I'm going to do these more quickly than the other ones. I'm not going to like do as much explanation. I'm just going to kind of get to the chase. This right here, you should see this is chain rule. Derivative of the outside says 2 sine 3 minus x times the derivative of the inside. The next inside is sine, so it's going to be cosine 3 minus x. Then it's going to be the derivative of the inside of that, which is just negative 1. Okay, so then I'm going to plug in a 0. This is f prime of x equals that. Then I'm going to do f prime of 0, plug in a 0 everywhere. So it's going to be 2 sine 3 cosine 3 negative 1. So when you combine the negative 1s, you're going to get that negative 2. So negative 2 sine 3 cosine 3. It is B. This one, another chain rule. Outside first, 5 x over x plus 1 to the fourth, then derivative of the inside. The inside is a quotient rule. So it's low d high, x plus 1, derivative that's just 1, minus high x, d low is just minus x, over low squared, x plus 1 squared. This is going to simplify to just 1 over x squared. Because the x's will cancel here. So it's 5 x over x plus 1 to the fourth times 1 over x plus 1 squared. I'm not seeing that over here, so I got to simplify it a little bit more. This I can rewrite as 5 times x to the fourth over x plus 1 to the fourth times 1 over x plus 1 squared. And then I'm kind of multiplying the numerators here, so I'm going to get 5x to the fourth on top, that's that. And then on bottom, x plus 1 to the fourth times x plus 1 to the second is x plus 1 to the sixth. So I do see that somewhere. 5x, yeah, it's D. Okay. 3, if f of x equals 2x plus 1 to the fourth, find the fourth derivative of f of x at x equals 0. Okay, so we're just going to keep taking the derivative of this. So first derivative is 4 2x plus 1 to the third times 2. Second derivative is 12 2x plus 1 squared times that 2 times another 2, because I'm multiplying by 2 again. The third derivative is 24 2x plus 1, just that, times 2 times 2 times 2. It's another times 2 because it's in there. I'm going to take a second to clean this up. This is now 2 times 2 is 4, times 2 is 8, 8 times 24, 160, 190, 160, 192, 192, 384. So it's going to be 384x plus 192. When you clean this up, and ideally, I guess you should have been cleaning that up as you were going along. This is where I'm at. Then that's a triple derivative. So then the fourth derivative, 1, 2, 3, 4 of x is just 384. So the answer is E. D, the derivative of 2 sine root x squared. This is chain rule. So first we have 4 sine root x. I'm going to cut this off. Yep, times then cosine root x times 1/2 x, and negative 1/2, which is the same as 1 over 2 root x. Anyway, so I'm looking for this 4 sine root x, cosine root x. I see it, but it's gonna have to be. I gotta sort this out. So let me sort this out. This 1/2 x to the negative 1/2 is the same as, I'll show you over here. This is the same as 1 over 2 root x. So I'm just gonna move this to the denominator here. This is just 2 root x in the bottom. So now I can simplify. This will just become a 2, and then I'll have that. So it must be D. Okay. Keep going. 5. If y equals 2 cosine x over 2, then what's the second derivative? First derivative is going to be 2 negative sign x over 2 times the derivative of the inside, which is 1/2. So that's going to simplify to, that's a 1. So it's going to be negative sine x over 2 because the 1/2 and the 2 will cancel to be a 1. And then I got to take the second derivative. So it's going to be derivative of this negative cosine x over 2 times 1/2 because there's a 1/2 on the inside. So it's, I see it, it's e. Okay. This is fundamental theorem of calculus with chain rule. Take the x squared, put it inside the t. So we're going to have root x squared times 2x. And there's no values here. So it's just x times 2x, which is just 2x squared d. Same thing here. Take the x, put it in for t. It's 1 over 1 plus root x squared times the derivative of root x. I really think it's worth knowing that the derivative of root x, because it just comes, the derivative of root x is 1 over 2 root x. It just comes up so often. It's just kind of nice to know that. So when you multiply the derivative of root x, it's just 1 over 2 root x. So let's see here. Yeah, it's just, what's the difference between these two? Yeah, it's this one, because this will become 1 over 1 plus x times 1 over 2 root x. And when you multiply them, this is a plus here, and it's hard to see that, but that's a plus. That is it. Okay. 5. This is a similar problem to that we had earlier. You have derivatives, you have a second derivative, and you're asked which of these are true. Again, I'm not going to explain it. I'm just going to do it. If you look at 2, it's 0, so it's a critical point, and it's negative. So we see f prime of x is 0, and f double prime of x is less than 0. So that means, again, concave down, it's got to be a relative max. So we definitely have a relative max at 2. This is true. And we do not have 1 at 8 because it's 0 and 4 is positive. That's a relative min right there. So only 2 is true. An equation of line tangent to curve at 1, 5. Okay. Yep. All right. So line tangent, like I said before, y minus y1 equals m parentheses x minus x1. This is your x1. This is your y1. Gives it to you. So it's going to be y minus 5 equals some m. I have to find that still, x minus 1. Okay. So then I have to find the m. To find the m, I'm going to find y prime. Y prime is low, 3x minus 2. D high is just 2. Minus high, 2x plus 3. D low, which is 3. All over 3x minus 2 squared. Plug in a 1 into that. That's just a 2. 2 minus 5 minus 15 over, that's 1 over 1. So 2 minus 15 is negative 13. So my m is negative 13. So this is a negative 13 here. It's kind of written in a weird way over here with x's and y's on one side and the constant on the other side. So let's reorganize this. This is going to be y minus 5 equals negative 13x plus 13. Move the 5 over, and then move the x over. It's going to be y plus 13x equals 18. I see that right here. It's b. The graph below, function of g shown below. F is the function given by f of x equals g of g of x. What is the value of f prime of 0? Same thing as before. You always like write out symbolically what this is. So it's g prime g of x. I'm being dumb. F prime of x equals g prime g of x times g another g prime of x. This is like it's like a chain rule, but it's itself. So it's the outside, which is g prime of g of x, and then times the derivative of the inside, which is also g of x, so that's why it's in a g prime. Then you plug in a 0 into it, so f prime of 0 equals g prime of g of 0 times g prime of 0, and then you go find it. So g prime of 0, the slope at 0, kind of hard to see, but you can do it. It's just 2, right? It's going over 1 up 2, so that's just 2. And then g of 0 itself is 3, so we want the slope of it at 3, which is right here, which looks like it's going over, it's just like negative 1. So negative 1 times 2 is negative 2. Okay. Last page, here we go. 11. The graph of a function f consisting of like 3 line segments shown above. The function f is defined on the closed interval 0 to 6. Let g of x equal the integral from 2 to x of f of t dt. What is the maximum value of g of x? So it's a value. It wants the y. It does not want the x. It doesn't tell me any starting values. So it just tells me that we're starting at 2. So you're like, your beginning is here at 2. So you need let's do candidates test. Okay, candidates are 0, 3, because that's where it hits, where f prime of x, where g prime of x equals 0, which is the same as saying where f of x equals 0, that happens at x equals 3. That's why 3 is here. That's the critical point. Okay. And then at 6. So we plug them in. The integral from 2 to 0 is going to be just this area here, which is 2 times 2. But since we're going backwards, it's like a negative 4. So 0 is negative 4. Going forwards here, we have this 2 by 1, so it's just 1 at 3. And then we're going to subtract another 1 here, and then another 4 here, so we're going to get down back to negative 4 here. So your maximum is going to be 1, b. 12, f of 9 is 18, f prime of 9 is 7, g is the function defined by g of x is f of x over root x. What's the value of g prime of 9? Same thing. Write it out symbolically first. G prime of x equals low root x, d high f prime of x, high, minus high f of x, d low, which is, I just went over this, but it's 1 over 2 root x, all over low squared, which is just x. Then we plug in a 9 into that, so g prime of 9 is going to be 3 times f prime of 9 is 7 minus f of 9 is 18 times 1 over root 9 is 3, 1 over 6 all over 9. So it's at 21 minus 3 over 9. It's 18 over 9. 18 over 9 is 2. The answer is 2. A. Okay. 13. Okay. This chain rule. Let's just write it out. The chain rule: f prime of f prime of g of 3 times g prime of 3. We just go find it. So g prime just is 3. That's easy. So that's just 3. G of 3 is 7. So this is just f prime. What is f prime of 7 times 3? Okay, that means to find f prime of 7, so I have to find f prime. F prime of x is a little trickier. It's going to be 1 over 2 root x squared minus 4 times 2x. Then I plug in a 7 into that. So it's 1 over 2 root 49 minus 4, it's 45, times 14. So that's 7. It's going to make that 7 7 over root 45. This is 7 over root 45 times the 3. It's 21 over root 45. Root 45 can be simplified to be 3 root 5 because it's like root 9 times root 5. So this is 21 over 3 root 5. Those simplify, so it's 7 over root 5. That is A. Okay, 14. F is the function absolute minimum. Okay. So absolute minimum, candidates test, boom, boom, x, f of x, get used to it. Absolute value, absolute minimum, you're going to find candidates test. Let's go ahead. Okay, we can put 1 and 5 halves on there because there are endpoints, and then we'll find the critical points, which is going to be 6x minus 3x squared. Let's set that equal to 0. That's my derivative right here, just so you know, f of x, f prime of x. So set that equal to 0. Let's factor out the greatest common factor, which is going to be a negative 3x. Take that out of everything. You're going to get negative 2 plus x equals 0. So my two values are going to be x equals 0 and also x equals 2. So those are my two things I got to try. But 0 doesn't count because it's not within the interval, so I don't have to worry about the 0. Now let's plug them in. I have 3 minus 1, which is just 2. Remember, I'm looking for the minimum. Plug in the 2. 4 times 3 is 12. 12 minus 8 is 4. So that's out. And then I've got 5 halves. So what, that's 20. See, this is, okay, 25 over 4. So it's 3. I'm doing it over here. F of 5 halves is 3 times 25 over 4 minus 125 over 8. So 3 times 125. 3 times 125 is 75. So I have 75 over 4 minus 125 over 8. I'm going to simplify the fractions, multiply this by 2 over 2. So I'm doing 2 over 2 times this. I'm going to get 150 over 8 minus 125 over 8. That gets me 25 over 8. Okay, which is like, which I see here, you know, as a possibility. But that's not, 25 over 8 is like a little bit over 3 because 3 times 8 is 24. It's like a little bit over 3. So it's got to be 2. The absolute minimum value is 2 because that's bigger than 2. It's the smallest one is here. Okay, 15. The figure shows the graph of differential function f from negative 1 to 1. How many critical points does the graph y equals f of x squared have on a given interval? Okay, so critical values happen when the derivative equals 0. So we need to find the derivative, which is going to be 2 f of x, f prime of x. And so how many is that going to have? Like how often is that going to equal 0 is the question. Well, this is a funny problem. There's 3 times it's going to happen. It's 3. And I know it's 3 because here are the options that could happen. I have this point right here, that this f of, I don't know what that is, but that's going to make that 0. And then I also have prime equaling 0 here, f prime of x equals 0 here, and f prime of x equals 0 here at this like horizontal tangent, and then also f of x equals 0 here. So at these 3 distinct points, this is going to equal 0, so it's going to be 3. I like that question. It's kind of interesting. F be the function cube root of x. What's the approximation of f of 10 using the line tangent of the curve 8, 2? Okay, so same thing. Line tangent y minus y1 equals mx minus x1. My x1 is 8. My y1 is 2. Start with that. Y minus 2 equals some m, which I don't know yet, x minus 8. Good. Do what you can so far. Now, I gotta find f prime of x, which is 1/3 x to the negative 2/3, which is the same as 1/3 cube root of x squared. Okay, and then I'm going to plug in a 2 into that. So it's 1/64, the cube root of 64, which is 4. So it's 1 over, I'll show you what's going on. I'm plugging in an 8 into this, so it's the cube root of 64. The cube root of 64 is 4. So it's 1/12, because 4 times 3 is 12. So that's my answer here, it's 12. And then I'm going to plug in a 10 into that. So it's going to be 10 minus 8 is 2. So it's 2/12 plus the 2. This ends up being y equals 2/12 plus 2. And what I did there is I'm just putting that 10 in for x. It's 2 times 1/12 is 2/12. Then I added the 2 over. You see what's going on, right? So then that is the same as 24/12 plus 2/12 is 26/12. I'm going to put it up here. This becomes y equals 26/12, which is divided by 2. It's 13/6. Phew, that's me done. That's 13/6. I'm very curious how long this video is going to be in the end.